Hi there! KAIWEETS sent me this smart meter together with the KM601S that I reviewed recently. I guess I'm off their Christmas list after that one. Anyway, I hope this review of the KC602 goes better. I mark this video as a promotion because I did not pay for the meter, but you know that you always get my honest opinion. The KC602 is a smart clamp meter and comes in a nice pouch. It has a decently sized and well-written manual that's all in English. In the pouch you find a set of probes and a K-type thermocouple, a set of 3 AAA batteries and the meter itself. The battery compartment has a metal threaded insert, which is nice, but the screw itself is not held captive in the lid, and so it can get lost easily, as it almost did here. At every power up, the meter goes through a self-calibration cycle before it's usable. The whole thing takes about 6 seconds, which doesn't sound like a lot, but it gets pretty annoying when you want to just grab the meter to measure something quickly. The leads go into the rear, and sadly the only way to find which socket takes the black lead is to look at the label on the front. I recommend to use a marker and draw a black ring around the left terminal. Apart from the power button, there are 3 other buttons on the front, each having a double function. On the right side is another button with a double function for hold or flashlight. A short press is for hold and a long press turns the flashlight on. Initially I found the flashlight weird because it mainly illuminates the inside of the clamp, but I guess it makes sense if you try to clamp the right wire in the dark. By default the meter shows the temperature in Fahrenheit, but I'm thinking in Celsius, so this was the first thing I wanted to change. And this is far from easy. KAIWEETS has a video on their website on how to do it, and apparently you're expected to follow this. I tried and failed many times. No verbal or written instructions, and the KAIWEETS engineer is going through the motions at lightning speed. Anyway, at last I succeeded, and for all of you who want to do it, I will show it now once more. By the way, you should not have the leads connected to the meter during this process. You take a battery out, and then, before inserting it back, press hold and keep it pressed. Then, while the meter is still showing all segments on the display, let go of hold and start pressing it with short presses repeatedly. If your timing is right and the stars align, you now get a screen showing briefly U.100, which is probably the firmware version or something like that. I think you are now in a genuine calibration menu. The exploration of I will leave for another day. Because of the danger to mess up calibration, you do not want the leads connected and do nothing but the short presses on the power button. This will eventually get you to the temperature function. Pressing cell now allows you to toggle between Fahrenheit and Celsius for the upper display. When done, do a long press of power to save it and get out of calibration. By default, the meter is in auto mode, hunting through the most left 4 functions marked in green. A short press of auto func gets you into the DC amps function. Pressing cell toggles to AC amps with frequency. Another push of cell gets you into inrush, and the next press gets back to DC amps. The next short press of function auto selects DC volts, and cell toggles between DC and AC volts. Then there is ohms and continuity. On any of the functions, a long press on auto function brings you back into auto. As with the KM601, if you overshot the desired function, you have to either use that to restart from the left or keep pressing to go the long way around. The KM601S improves on this by allowing to go left or right. Anyway, let's proceed to diode and to millivolts, which can also toggle between AC and DC using cell, frequency, which also shows duty cycle, capacitance, temperature, and NCV that can toggle between NCV and live, and back to auto. Auto mode is very convenient and you really can't make any mistake. Just use the probes on anything you want and the KC602 figures out what to do, be it DC volts, or AC volts, resistance, continuity, that is resistance with a beep below 50 ohms, or even AC or DC amps using the clamp. Without having to select anything, just power it on and the KC602 delivers the goods. And it does so well within its specs. I spare you the tediousness of checking each function, but I did verify all of them against my references and found no issues. I will show a few highlights later, mainly quirks that you should be aware of. I measured the bandwidth of AC volts to be just above 2 kHz, which is normal for this kind of meters. DC and AC amp ranges go way higher than anything I could accurately verify against my references, but as far as I could test, everything was fine, so I don't expect any problems at higher values. I'll talk a bit more about inrush a little later. Of note, unlike other auto meters I tested before, the KC602 has no issue measuring accurately below 20 ohms, which is really a pleasant surprise. A quick look at the amps. The lowest range on the KC602 is 60 amps. It is simply not meant for electronics, so it's no wonder that it struggles below 0.5 amps. From then on it's okay. On AC it's exactly the same story. You can't use it to investigate the small earth leakage currents that can cause nuisance tripping on RCD or CFCIs. There are special clamp meters for that, and the KC601 isn't one of them. Moving on, I tested the capacity measurement, and 1 nanofarad is pretty much the lowest value you can reasonably measure. Having no supercaps lying around, I stopped at 4700 microfarads, but everything was fine in that range. Frequency works well, but beyond 3 MHz the meter needs more than 1 volt RMS. The KC602 may go further than 20 MHz, but that's when it needs more than the 5 volts peak to peak my signal generator could deliver. No issues with duty cycle, which was spot on. And temperature was fine too. With that out of the way, a quick note how I tested some of the more unusual stuff. For AC currents beyond 10 amps, I used this setup. This old low impedance adapter is basically a transformer with massive copper bands on the secondary. Basically you trade low currents and tens of volts on the primary side to fractions of volts but tens of amps on the secondary. I shortened the secondary terminals with a copper wire which goes through the KC602 clamp and the clamp of my Fluke i1010 adapter. That adapter produces a voltage of 1 millivolt per amp, which is measured by my BM869S. The other meter on the far left is just a monitor for the current on the primary to avoid overloading the insulation transformer acting as a source. Measurements have to be quick because the short circuit wire gets very hot. I paused the video for a moment. For actual measurements I used the hold button on both meters to note down the values. The KC602 is in line with the Fluke, and that's as good as I can verify it. Well, initially I did a few tests against other current clamps that I have, and they all agreed to within tolerances with the Fluke and the KC602, so I just used the Fluke for most of the verification. While we're at it, just a note, on the KC602, like most multimeters, the max function stops the auto range to work. So if your currents are beyond the 60 amp range, all you get is an overload indicator. That happens to other functions as well, and as I said, most meters have this limitation. But then most let you select manual range, which allows you to overcome this limit, but the KC602 doesn't have manual range. Anyway, for AC currents only, the KC602 offers the inrush function as an alternative. I'm using the crest function on the Bryman and inrush on the KC602. Both meters display the highest reading until you reset them. The Bryman reads nearly 115 amps, while the KC602 shows basically the same as before, 83 amps. That discrepancy kind of worried me. To explore this further, I expanded the setup with another current clamp and my Fluke 187. To rule out that the Fluke i1010 current clamp had anything to do with the discrepancy, I moved it to the Fluke 187 and used a different clamp which does 10 millivolts per amp on the Bryman. The Fluke has two modes, normal min-max and fast min-max, which is more like the crest mode of the Bryman. Trying the normal min-max first, the Bryman crest mode registered 121 amps with the other clamp, while the Fluke is in line with the KC602. Repeating the test with a fluke set to fast min-max, and now I get a value that matches what the Bryman measured with the same probe before. The Bryman manual states that the crest captures signals as short as 1 millisecond, while Fluke claims that fast min-max captures peaks even down to 250 microseconds. The KC602 manual doesn't state how fast inrush is, but we can conclude it's slower than 1 millisecond. I looked at other comparable clamp meter specs, and it seems that inrush function works more in the 100 millisecond range. My setup doesn't produce that kind of slower inrush, so I think it's fine that the KC602 is not capturing the ultra-fast inrush here and showing the typical max value instead. Moving from high currents to low volts. The KC602 is in auto mode and has picked DC volts. The other meter shows the current drawn by the KC602 from the source, about 1.6 microamps. Now 1.5 volts over 1.6 microamps means the input resistance of the KC602 in DC volts is only about 937 kiloohms, much lower than the usual 10 megohm of not so smart multimeters. It is not a disaster, it's still high enough for electrical works and many measurements in electronics, but it's something to be aware of. I said that the KC602 is in auto mode, but sadly it doesn't show that fact on the display. It makes a difference because if I lower the voltage, there comes a point where auto mode decides for you that the voltage is too low to be worth measuring. The manual says below 0.6 volts, but in my meter it's 0.4 volts. It is now in hunting mode again. If I lower the voltage further, it suddenly decides that you obviously want ohms. The problem with that is that in ohms mode the meter is an active source of current, and so instead of drawing current it suddenly feeds 60 microamps back into the batteries. The negative sign indicates the current flow has reversed. I'm not a fan of this. While I doubt that it may kill some sensitive circuit, it will probably change its behavior, and a meter should not do that to the thing it's measuring. Starting from the same point, but now I switch the meter manually into volts. Note that the current at 1.5 volts is still the same 1.6 microamps, so manual function select does not improve the input resistance. But if I reduce the voltage as before, below the 0.4 volts, nothing happens. The meter keeps measuring properly as you would expect. Actually, what you would expect is that it switches automatically into the millivolts range, but sadly that doesn't happen either. And to go manually into millivolts, I have no choice but to select ohms first, followed by continuity with an even greater backfeed current, but which is insignificant compared to the whopping 1.6 milliamps of current the diode function decides to inject into my setup. Until I get to millivolts and everything is back to normal. By the way, the behavior is exactly the same for AC volts too. It would have been easy to put the volts and millivolts function next to each other to avoid that, which is what basically every other multimeter does, but that would have spoiled the concept of the leftmost 4 green auto functions with a hunting indicator. I agree that it's a neat concept for those who never care about millivolts, but it's not great for electronics work. While in the previous example the diode function was most unwanted, let's see it working when you do want it. Testing a single diode works fine, and so does 2 in series, no diode beep by the way, and no reading in reverse direction, which is fine. A single red LED lights up brightly and the forward voltage is shown. 2 red LEDs in series light up very dimly and no voltage is shown. A yellow LED lights and the 1.9 volts forward voltage is shown. A single white LED lights and the 2.6 volts forward voltage is shown, but 2 white LEDs in series cannot be tested. This all works as expected. And since you just saw me using the delivered test leads, they are surprisingly short, both in the probe size itself and the cable length compared with more standard test leads like this one from the KAIWEETS 601S multimeter. The cable is PVC, relatively stiff. The cable on the KM601S leads is also probably PVC, but feels more pleasant and is marked as 20 AWG and rated 2000 volts, while the cables on the KC602 are not marked at all. Well, let's stick with the leads that came with the KC602. The protection caps can be removed, revealing tips that are not particularly sharp. Okay for electrical work, less so for fine electronics. There's a holder at the side of the clamp which can take a lead to allow you holding the meter while probing something. Now, if you try that in low light conditions, the flashlight function is of little help because it mostly illuminates the clamp. You can, of course, open the clamp and that definitely improves the light on the thing you are trying to probe, but the pressure needed to keep the clamp open is quite high. You don't want to do this for long. The NCV function works, but it's not very sensitive. You need all but touch the live wire before it triggers. But once that happens, it's kind of latched. You can pull away and it still beeps at quite a distance, which is kind of confusing if you want to examine the next wire in a row. The live function is reached by pressing select in NCV mode. It works with a red test lead. If that touches a live wire, the meter beeps. It works well and I definitely prefer it over the KC602's NCV function. The obligatory continuity test with the provided test leads, and it is not great. For some strange reason, the beep gets louder if you leave the probes connected longer. Same test but with Pomona probes and it works much better. Other brands are of course available. You can easily improve on KC602 by replacing the included test leads with better ones. Smart meters with their always backlit display are quite power hungry and the KC602 is no exception. In normal hunting mode it draws already nearly 36 milliamps. That did not change if you manually select each function. The flashlight will push that up by another 10 milliamps or so. As always, the beeper draws a lot more current. In the KC602 it's more than doubling the normal consumption to 75 milliamps. Let's see when the low battery symbol comes on and how accurately the KC602 measures with a low battery. The battery voltage is shown by the meter on the right. I show this accelerated in the interest of time. At 3.55 volts, the low battery warning appears briefly but goes away after leaving the voltage stable at that level. At 3.47 volts, the low battery warning is definitely there to stay. That means 1.16 volts per cell, not too bad. This definitely allows the use of rechargeable batteries with a nominal 1.2 volts per cell. As the battery voltage drops further, the measured value doesn't change, but the display gets dimmer and dimmer, and at 2.6 volts it has faded to be completely dark. That is pretty impressive, of course, as it means you don't need to change the batteries right away when the warning appears. Last not least, in the battery life investigation, the KC602 has the usual 15 minutes auto power off that you can disable by pressing auto while powering on the meter. It will still beep annoyingly, but not power off. Anyway, I want to see how much current the 602 draws when it's off. 6 microamps is quite good. I would still take batteries out when you are not using the meter for a long time, but that's because of the danger of leaking batteries, not because of discharging them. The KC602 opens fairly easy. The rear contains the battery compartment that has tabs that connect to springs on the PCB, a good solution. The PCB looks fairly clean. No fuses anywhere, but that's okay in this case as currents are measured by the clamp. Of note, in the lower right, a single PTC as input protection. Then we have the two 5 megohm resistors that would normally give the meter the expected 10 megohm input resistance, were it not for the mere 330k resistors in series courtesy of the auto function. That tracks it down to less than 1 megohm. As for the chips, nearly everything is done in the DM1106EN, which is a dedicated DMM and true RMS chip that is also used in other non-smart meters. There's a quad op-amp, an EEPROM, and a large mystery chip that had its markings sanded off. Given that the processor is not specifically for smart meters, it might be that this mystery chip contains the smarts. The big white thing is a relay. All in all, the KC602 is a capable clamp meter, and I want to thank KAIWEETS for sending it in. As is usually the case with clamp meters, the target use is not measuring delicate electronics. As long as you're aware of the constraints and like the auto function, the KC602 is certainly a meter to consider. If you like my videos, don't forget to subscribe. There are many more projects, repairs and reviews coming up. And it would be great if you decided becoming a Patreon. That would really help this channel. Thanks for watching.